morning, students. Today we will continue our journey of Python with inbuilt functions, specifically to type conversion functions. You know very well, functions are groups of statements perform some specific task when executed. We have discussed and you are very well familiar with the functions. Here some of the inbuilt functions that are available in Python that we are going to discuss. Functions, you know, that is function is the name, some of the parameters that you require to give to function. Function will perform some operations, some of the process it will perform to get desired task, and then after it will return some value. Python, again, similar to other programming languages, it gives a number of inbuilt functions, but today that we are going to discuss that is related to data type conversion functions. In programming, we require to perform many operations in which one of the important process that is to convert one data type to another data type. Here all these functions that we are going to discuss that will help us to convert from one data type value to another data type. So let's start. Data type conversion functions. Sometimes it is necessary to perform type conversions between the built-in data types. For example, if you are given two strings, each string contains some number. For example, string 1 contains number 12, another string contains number 10. It is not possible to add these two strings. 1, 2, another string, no doubt it is a number, but it is stored as string object. Another string also, that is the 10, that is 10. So if we want to add these two strings, Python can only add two strings, but the result, you know, the adding of the two strings, that is the concatenation, that is, it will give you 1210, but that we don't want. We want to get the sum of 12 and 10, but these two are stored as strings, so we require to convert into numbers. So we will use type conversion function. First, we can convert 12 to integer number, 1010, that is string, to integer. After getting these two numbers, now if we will perform plus operation, definitely it will perform exact addition that we want, that we desire to get the outcome, that is 22, 12 plus 10, that is 22. To convert between types, we use the type name as a function. See the simplicity. You do not require to remember any function to convert from one type to another. Just you require to use the type name as a function. If I want to use integer, I will have to use int. If I want to convert to long, I will have to use long. If I want to convert to float, I will have to use float. Means what the data type is associated that name function with the same name in form of function we can use to convert in desired data type. Python provides built-in functions to perform conversion from one data type to another. Built-in functions, you know very well, that are ready-made available. We do not require to write ourselves function. No doubt we will have to write our own functions as we have written as in form of user defined functions, UDF functions, but here only we will see about built-in functions. Built-in functions means ready-made available. Only we require to get the syntax of the functions and what actually the function performs, only the thing that we require to understand. These functions return a new object representing the converted data type value. For example, as we have seen, 1 2 that is in string. After converting, this function will return converted data type value, that is 12, and it will return a new object that is of type integer and value 12, and that we can use or manipulate or we can store in our variable. Here first function that we will see, that is int, argument that is of x, whatever the x that is type, and here optional base, if it is x is string then only we can use, here it is base, so converts x to an integer number. Base represent the base of x. If x is a string, we will see example, then it will be clear. If x is a string, then we must have to give base. If we do not give, it will be treated as by default base 10. Otherwise we can specify 2, that is for binary. If we will specify octal, then it will be treated number that is octal or hexadecimal, whatever the number type. Now n equal to first statement 10.10. n1 equal to integer n, so type of n that is of float, real, but I want to convert it into integer. So what the function? Same way, integer, int, you know very well, that is the integral data type, number without decimal point. So this n that is of real type will be converted by int function and it will return an integer object. This integer object will be stored into our variable n1. So print n1, it will print actually 10, number without decimal point. It is possible. Other two functions that we have not discussed, but we will discuss soon after this example, that is binary n1. It will give you equivalent binary of this 10. You know very well binary of this number, that is 1010. 4 bits are used. So equivalent binary of number 10, 1010, that will be printed. Same way, octal, how can exactly 10, that is integer, it's octal. What will be the octal? It will give you the octal value of number 10. How you are calculating octal number of given number? Here you are dividing the number 10 by 8, and what the remainder that you are storing, that is dividing 10 by 8, and you are taking 8 1 8, so value, and remainder that will be 2, so 2 that will be there after this division. So 1 2 2 into 8 raised to 0, that is 2, plus 1 into 8 raised to 1, that is 8, 8 plus 2, that is 10. The answer will be 12. Now you know what the equivalent of value 10 in hexadecimal. You know very well. A, that is used to represent value 10. You know 0 to 9 symbols. Then 10, actual 2 digits are there to represent 10. In hexadecimal, we use A. To represent 11, we use B, then C, D, E, F, up to 15. So output should be here 10, that is integer, equivalent binary, that is 1010, 12, that is octal, and A, that is hexadecimal. Let's check the output. It is expected. See, here it is decimal number. Here 0B means 1010 is a binary number. 0O means 12 is octal equivalent of this 10. 1010 equivalent binary of this 10. And you know very well hexadecimal 0xa. A is actually equivalent hexadecimal value for decimal 10. So 3 more functions that we have seen, that is Hexadecimal, it will convert an integer to a hexadecimal string, means integer 10 that is converted to hexadecimal string. Octal x, x was integer that we have seen, converts an integer to an octal string that we have seen, and binary x converts an integer x that is to an binary string that we have seen 1010. We have got the output string that is 1010. Let's check another example, that is what if in this previous example here that we have seen n was the real, but what if it is string? As we have seen, base represents the base of x if x is a string. So now we will convert x that is string by giving this base value, and what the output that we will see. Here number type 101 that is of type string. Now I want to create this string and want to convert to integer, but now I want to take base equal to 10, means I want to convert this number to decimal. So you know very well, in decimal number system the value of this that is 1, here the value of 0 that is 10, value of this one that is 100. So 100 plus 1, it is equivalent to 101. So first output that will be 101. Now if I want to convert this given string to an integer with having base 2, so you know very well, here base 2 that is of binary number. If I want to convert into equivalent decimal number, then you use 1 into 2 raised to 0 plus 0 into 2 raised to 1 plus 1 into 2 raised to 2. So 1 into 2 raised to 2 that is 4 plus 1 5. So binary equivalent 101 in decimal we want to get answer that is integer value 5. Base equal to 2 means this number is binary. So 101 equivalent decimal that is 5. So this will give you equivalent of this binary number 101. Why? Because we have given base equal to 2. So by converting this binary number to decimal number, we will get value 5. So first that is 101, second output that will be 5. Now if we will create this number that is base equal to 8, if we create 101 as an octal number, so 1 into 8 raised to 0, 1, 0 into 8 raised to 1, 0, remember 1 here, and 1 into 8 raised to 2, 64 plus 1, 65. So here equivalent decimal of this given octal number that is 65. Same way, if the string that is given, it is of base 16 integer number. So here 1 into 16 raised to 0, 1, 0 into 16 raised to 1, 0, 1 into 16 raised to square, 256, 256 plus 1 that will be 257. So output will be 101, 5, 65 and 257. Let's check the output. Here it is decimal. Why? Because it was a decimal number. Here equivalent of 101 binary number, it is decimal 5. Equivalent of 101 octal number, that is decimal 65. And equivalent of 101 hexadecimal number, it is equivalent to hexadecimal 257. So we can convert any number, any real number to integer, any string to an integer number by giving specific hexadecimal, octal or binary number, what the string actually it represents. Now similar to integer, another function is there long to increase range of value It works similar to integer, converts x to a long integer, base represent the base if x is a string, similar to what we have seen. Only here the range of value that is more compared to integer. And last one, that is float x, converts x to a floating point number, means the given number or given string in different form, it will convert into equivalent float. Let's check the example of float and string. Here the string contains 101.191. It is in string form. We want to convert it equivalent float number. So what? N1 equal to float n. 101.191 is a string. This function will convert this string to equivalent real number, real float, and after this print n1, it will display float 101.191 type. Second example, C1 equal to complex 1, 2. Complex 1, 2. It will create a complex number. Complex number, first argument, you will see here that is a real part of complex number, and second 2, that is an imaginary part. So here I am giving constant to this C2, here 1 minus 3j. 1 that is the real, 3j that is minus 3j that is the imaginary. Here the 1 2 form, it will create complex number 1 plus 2j. So 1 plus 2j. After adding these two complex number, real part of this number will be added with real part of this. So here 1 plus 1, 1 plus 1, it is 2. So outcome of this 3, that will be 2. But here imaginary part 2, here imaginary part that is minus 3. So 2 minus 3, that is minus 1. So minus j. So output will be here 1 plus 1, 2, that is real, and minus j. So it will be 2 minus 1j. Another that is integer s equal to 10, s1 equal to strs. We want to convert this integer number to string, opposite to what we have done previously. In previous example, we have converted string to integer. Here integer 10 is converted to string. Then we have printed both s and s1. So both are 10, but s that is an integer, s1 that is of string. And here type s, type s1. Type function will take an argument of any variable or value or constant, and it will return the data type of that particular object. So you know very well, type of s that is of integer and type of s1 that is of string. Why? Because this will create a string object from this s and will assign to s1. So s1 that is of type string. So let's check the outcome. Here string to float 101.191, that you are aware, that is a real number. Second, that is the complex number. First complex number, second complex number. 1 plus 1, that is 2, and plus 2 minus 3, that is minus 1j. And last one, that is type SS1, both will be displayed 10 10, and the type of both, that is the important, that is here it is of integer, here that is of string. So output here that is integer, and here that is of string. Output of print SS1 will display both the values as 10, but here it is an integer, here that is string, means type of here s that is of integer, type of s1 that is type of s1 that is of string. Another function, as we have seen, complex real, optional imaginary part, it will create a complex number. strx converts an object x to a string representation. Both these functions that we have seen in previous example, complex will create a complex number and str will create string object from given integer or real type. REPR represent x, converts an object x to an expression string. It will convert into an expression string We will see example of this. Represent x represent expression. R expression means regular expression. It will convert an object to a regular expression string. Evaluate string evaluates a string and returns an object. For example, if string contains some numerical expression and we want to evaluate it, what will be the answer of that expression? We can use evaluate. And tuple s converts s to a tuple, means s is converted to a tuple. That we have seen it is similar to a list, but we are not able to change that we have seen. So another that is list x. We have seen list data type also converts s to a list. S, whatever the string or any other objects are there, it will be converted into list. Set s converts s to a set. You know very well what the set is. In mathematics, you know set does not contain any repetitive values and it is used to represent set of values. Dictionary D creates a dictionary. D must be a sequence of key value tuples. So here it must contain a tuple and all are in key value pair. So let's see another example. Here S, that is BCA, S1, that is represent regular expression. S converts to an expression string. Print S1, again it will be of value BCA. C1 equal to complex one, to that we have seen. It will create a repair. C1 here must be C1 and then we will print C1. So here it must be print a converted string to a complex number value equivalent string that will be printed. And last one, s equal to 2 plus 5 into 3. You know it is a string. We must require to convert into value, then it is possible to evaluate. But using evaluate function, here 5 into 3 first, you know the priority of 5 into 3. So it will first multiply 15, 5 into 3 15 plus 2 17. So outcome of this will be, first it will evaluate s and then the result output will be 17. So output here, that is BCA, that is the regular expression string that is created from the BCA. More about this we will see the later units, fourth unit that we will have to discuss. 1 plus 2, that is the complex string created from a complex number, and 17, that is the value of the string expression. Not, it is not numeric, it is a string and we have evaluated this string expression. Next, that is the frozen set. You know, we not be able to change frozen set. CHRX converts an integer to a character, means actually it is a ASCII value or Unicode value equivalent of a single character. Converts an integer to a character. If we will give integer, so equivalent character of this x associated with x will be the outcome, that is a single character outcome. And opposite this character order, it will give you a value associated with a single character x. So converts a single character to its integer value. Here if we will give single character, it will give you the ASCII or Unicode value. As you know very well what the ASCII value. ASCII value means American Standard Code for Information Interchange, and it will give you the output of equivalent ASCII value. So these two functions, actually character and order, this function will convert from an integer to a character and from a single character to integer. Remember, here argument must be a single character string. As we use single quote to represent a string, it must be a single character. Otherwise, it will be in error if we will give more than one character in single quote. Why? Because ASCII value is always associated with a single character, not with more than one character. So similar to the concept of character that we have seen in other programming language like C, it is similar to this. Here it will give you ASCII value, and here it will, once we will give ASCII value, it will give you a character. Now let's see another example of this character conversion function. Here a equal to 65 and c char a. So what it will do, here integer a that is of 65, you know very well 65 is an ASCII value of character capital A. So what C will contain? C will contain character A. Same way, if we have C equal to single quote A, we want to get the ASCII value of that character A, we have to apply function order, ORD. See, once we are giving C single character, so it will give you single character A ASCII value. So you know very well small a, ASCII value of small a, you know that is 97. So output here that is 97. So first output that is capital A, second output that is the 97. So here A 97. It is possible, you know very well, we can perform some of the arithmetic operations and meaningful arithmetic operations on this character type also. But conversion we must require. For example, here if you will write CHR A plus 1, A plus 1, so 65 plus 1, 66. So you know ASCII value of 66 here, that is associated with characters capital B. So now C will contain capital B. Starting from 65, then in increasing order 66 associated with capital B, 67 associated with capital C, and so on. Same way, here C equal to character A. Order C means it will give you ASCII value of the small a. ASCII value of small a, that is 97. It is possible we can perform some arithmetic operation on this. For example, ORDC plus 1 if you will write, so 97 plus 1 that is 98. So A will contain 98. And to avoid the effect of these two functions, we can nest either of the function with each other, we will get no effect at all. For example, if you will write CHR in bracket ORD and whatever the character here, outcome will be the same character. Why? Because ORD will give you ASCII value, that ASCII value that we are giving to CHR, it will give associated character, so it will be itself A. So today we have seen number of functions from integer function to convert any data type string, real to integer. Then we have seen binary, hexa, octal also that we have seen. In that we have converted from different type integer to hexa and octal or binary. Then we have seen long, it is similar to integer but with increased range. We have seen that is of float to convert any string or number to a floating point number. We have seen that is complex to create complex number. Then we have seen str to convert to a string. Then regular expression rx expr, evaluate to evaluate, tuple to convert to a tuple, list to convert to a list, set to convert to a set, frozen set to convert to a frozen set, dictionary to create a dictionary but argument must be of tuple. And last we have seen that is CHR to get character from an integer, and ORD order to get ASCII value of a given character. So all these are the basic type conversion functions that we have seen with other functions. Next we will see other Python constructs in next lecture. Thank you. Have a good day. Thank you very much.